Hey everyone, I'm Josh Wolf. I'm a Senior Solutions Architect at Rancher Government Solutions and Chief Engineer at Platform One. And today I'm here to talk to you on behalf of both RGS and Platform One about DevSecOps at the new speed of government. So to kick things off, I wanted to set the stage of DevSecOps within the government first and foremost. Over the past few years, the DoD has been hard at work embracing DevSecOps throughout all of its organizations, and there have been many success stories, some of which I'll talk about here today, about how the DoD has drastically reduced the speed at which software is developed, accredited, and secured by adopting DevSecOps principles. One of the key outcomes of embracing DevSecOps is the Continuous Authority to Operate, or CATO, and this allows organizations to authorize repeatable, automated processes to build higher quality software in a fraction of the time. One of the organizations in the DoD that are leading this effort is Platform One. Platform One is a centralized DoD service, which, apart from some of the most unique logos and team naming conventions I've seen within the DoD, Platform One is equipped to accelerate DoD programs that are looking to adopt DevSecOps to build better software. So Platform One serves as kind of the nucleus for software factories within the DoD. It provides several key services, such as a DevSecOps paths available for organizations to develop using a CATO pipeline to accredit software faster. As well as other products for organizations looking to build their own software factory that stay in line with the DoD DevSecOps reference architecture. So while there are a number of Platform One services, more than a number, today I'll only be talking about three, and those three that are relevant to BigBang. But I encourage you, if you're interested in more, to find out more, to check out software.af.mil to learn more. So the first of these services that I wanted to mention is the foundation of everything else we'll talk about. And that service is Iron Bank. So at a high level, Iron Bank can be thought of as Platform One's DoD-flavored centralized image registry. With the help of various mission partners and private industry, various free and open source and commercial off-the-shelf products are distributed alongside readily available scans and vulnerability assessments. Containers are sourced from Iron Bank, come with many of their required security controls already addressed, ultimately easing the accreditation burden for systems that leverage them. Iron Bank operates just how you would expect other container registries, such as Docker Hub, Quay, or Artifactory. These images can be browsed and pulled by a Docker, Podman, or any of your Kubernetes clusters. If you want to, you're free to check out more at ironbank.dso.mil. The second service is PartyBus. So PartyBus is Platform One's fully ATO'd DevSecOps platform as a service. It's also Platform One's largest hosted environment, or environments. It provides a secure, distributed environment across multiple Kubernetes clusters at multiple impact levels and classification levels for users to onboard and begin developing, testing, and deploying software. As I said, it consists of multiple clusters, both for the software development tools and CI/CD workflows, but also the actual operational environments for things like the staging and production workflows or workloads. On the screen, you can just see a couple of the handful hosted products that Platform One offers. These are commercially ready available tools serviced by Platform One, where people can come and onboard and start leveraging. If you want to check out the full list, you're free to check out p1.dso.mil. And finally, PartyBus is also used as the model, kind of the reference that Platform One owns for other downstream software factories to adopt when they're building their own DevSecOps paths or software factory. Remember, Platform One's really that nucleus for other software factories to leverage and build off of. With that being said, that brings me to the third service and the focus of this conversation, BigBang. So BigBang is the product that assists in deploying software factories compliant with the DoD DevSecOps reference architecture. It serves as kind of the foundation and the building blocks for Platform One's own PartyBus environment, but also downstream software factories looking to repeatably deploy their own versions. It's a GitOps-based deployment product that bootstraps and maintains all the workloads necessary to run your own software factory. But before I actually get into the actual nitty-gritty details of BigBang, I just want to add just a little bit more context and the statistics behind the services that I just outlined. So the overall Platform One umbrella covers a lot of things. It covers 4 military organizations, over 25 companies. These are private industry companies with over 200 contractors. Iron Bank, the first service, contains about 500 or over 500 containers spanning various different types of workloads Partybus, the second service I mentioned, houses over 3,500 developers, producing over 40 different applications that have received their certificate to field through Platform One's continuous authority to operate pipelines and processes. And these applications are deployed, again, using Partybus environments in various production clusters across all impact levels and almost all the different classification enclaves. So servicing all these actual deployments is BigBang, the foundation, which is used to not only deploy and maintain Partybus, but also a multitude of other different software factories, just some of which you can see on the screen here today. So one of those foundations to all of this at Platform One is Rancher. Rancher is an original close partner with Platform One and has been here from the beginning. So unfortunately, I'm better at Kubernetes than I am at building charts. So you'll just have to imagine what Baby Yoda riding a blue cow looks like. But with that being said, at the heart of this partnership is the products that Rancher and the people that Rancher has embedded with Platform One. The first and foremost of that I want to talk about is RKE2, which is one of Rancher's premier Kubernetes distributions. So since much of Platform One's DevSecOps value proposition has its foundations on open source products, as well as the containerization and orchestration of said containers, Kubernetes is an essential component to all of that. Everything within Platform One, everything within the DevSecOps, the DoD DevSecOps ecosystem. So RKE2 is a free and open source distribution built specifically with government and restricted workloads at the forefront. And RKE2 is Platform One's open source distribution of choice for highly secure enterprise environments. It's the foundation for a lot of Platform One's most critical workloads. So just some of those, don't have enough time to go all over this, but these sort of workloads includes, but not limited to, the distribution for Platform One's own reference platform as a service, Partybus. It's the internal SIEM platform, the Kubernetes-based cross-domain solution. One of the cool ones that I like a lot is it is Platform One's core DNS-based public DNS services. This is a DNS that is leveraged both by Platform One, but other customers to manage the top-level domain of star.dso.mil. All the links you've seen me point to today, I'll leverage that DNS as a service. If you want to learn more about RKE2, you can check out my colleague Brandon Gullis' talk. This talk is going to be dedicated to strictly RKE2 and is also happening at SUSEcon. So although Platform One's core business model is not tied specifically to edge deployments, that doesn't mean that the DevSecOps principles stop at the edge, nor does Platform One's involvement. So K3S, which needs no introduction, is leading the charge there. So K3S has been used successfully to deploy to countless edge and low-powered devices within the government, within the DoD. One of the ones that Platform One has been heavily involved in is using K3S to take Kubernetes in flight. And this was done in collaboration with the U2 Federal Lab. It's a pretty cool success story. Within 13 working days, we used K3S to demonstrate in-flight software deployments with real-time updates on the U2 reconnaissance aircraft. In addition to that, with close collaboration from Hypergiant, we've also used K3S as the foundation for a satellite running AI ML workloads in space on commercial-grade hardware. So this is kind of paving the way for Kubernetes in orbit on military satellites. This deployment is expected to launch later this year. For a full case study, I highly recommend you read more about it at this link here. And finally, the people. So Rancher is an original professional services partner at Platform One, and we've been providing Kubernetes, DevSecOps, and general cloud-native expertise throughout the entirety of the program. We've got a lot of key engineers embedded full-time within virtually every area of Platform One, and one of which is myself. And today I'll be representing that as part of a core maintainer on BigBang. So now let's get into it. This is the meat of the presentation. We've briefly talked about where BigBang fits into the whole Platform One ecosystem. We've summarized Platform One as quick as we possibly can, given that this is a BigBang talk. And we've also talked about why BigBang exists to democratize software factories. So let's dive into what BigBang actually is. So at its foundation, BigBang is a US government-owned open source product used to bootstrap the foundational components of all Platform One environments. It strives to be vendor and infrastructure agnostic and be capable of deploying on almost any environment that runs Kubernetes. To better enable auditability and reusability, BigBang uses GitOps. This is specifically Flux v2 to provide a fully declarative deployment and upgrade pattern that remains consistent across all the different enclaves that Platform One customers live in. So think IL2, 4, 5, secret, top secret, you name it. This pattern is designed specifically to deliver a push-button software factory creation experience with the plumbing included. It serves as an out-of-the-box solution that meets the need of the 80%, while being configurable enough for the remaining 20% to customize for their unique needs. So as I've stated a few times, it's the foundation on which Platform One's own managed platform as a service, PartyBus, is built. And as such, we ensure that downstream consumers of BigBang also receive the same consistent representative Platform One experience. So BigBang itself is made up of several components. The product operates strictly on existing Kubernetes clusters. You see the arrows here operating above the infrastructure and Kubernetes layer. And it does so to best leverage the infrastructure agnostic API that Kubernetes provides. It's designed to work with any CNCF conformant distribution of Kubernetes. So everything that BigBang deploys is using the DoD approved containers from Iron Bank and uses Flux v2 as its GitOps orchestration engine of choice. So the two major components that BigBang has are segmented into core, and built on top of that is add-ons. In general, BigBang's capabilities are dictated by the DevSecOps reference architecture, such as leveraging zero trust, robust observability, enforcing policy, active runtime defense. This informs the decision-making on the actual tools and technologies chosen to fill those slots. So you can see on the screen, got several core capabilities, several add-ons. Most of the add-ons are optionally enabled. So the actual core components are chosen very carefully, usually only if they provide capabilities needed to be compliant. They generally serve as a platform's foundation for add-ons and any other customer deployments on top of that. These add-ons can range from CI/CD tooling to different collaboration tools. You saw earlier things like Mattermost, things like GitLab. These add-ons ultimately exist to provide Platform One's customers the full set of PartyBus capabilities for organizations looking to deploy their own software factories. So, as I've said, in general, all core components are required by the reference architecture, and add-ons are used to embellish that. So as for the actual tools and technologies chosen, this is a good example of the products on display. So as you can hopefully see by this chart, the vast majority of them are part of the CNCF landscape or from adjacent communities. So both Platform One and Rancher understand and respect the value of the open source community. We strive to evangelize it and also contribute back to the community. Unfortunately, not every open source product in the landscape meets all the demands of a secure platform in the eyes of the DoD, which is why you see a sprinkling of COTS tools in there as well. So also apparent should be the various infrastructure and Kubernetes distributions BigBang is tested on. Not only are we tested on, but also operate on in production today. So this ranges from the major unclassified CSPs, AWS, Azure, but also the classified environments as well, such as C2S. So that being said, I'd be doing a great disservice to the Kubernetes and CNCF community if I let BigBang take the bulk of the credit for that level of cross-compatibility. So with that being said, I want to address what I think is the elephant in the room. And that is using Kubernetes as a foundation for organizations' paths is not really a new thing. Many organizations around the world use exactly these same sprinklings of tools to do very similar things. What makes BigBang unique and what gives it its value is the level of integration between tools that BigBang provides, as well as the ease of use for customers deploying with BigBang. So in reality, everything is connected when you have a good platform. There are hard constraints, such as OPA gatekeeper needing to exist before enforcing policies for everything downstream. This is kind of to ensure that you're following your own guidelines that you set within the cluster. Another good example is Istio, which if you're leveraging the auto envoy injection process to make sure things are part of the data plane, you need to make sure Istio is fully enabled first and foremost before you install things that leverage Istio, like Jaeger. You've got a bunch of different soft dependencies as well. So one of the use cases is, let's say I choose Jaeger to have its storage backend as Elasticsearch. I need to make sure I have that configured correctly. Not only do I need to have Elasticsearch deployed, but I need to make sure Jaeger is configured properly to talk to that. Another common example is observability within these add-ons. So making sure GitLab has the appropriate centralized dashboards and authentication for the right people to see the right different types of metrics that are collected with Prometheus. The point I want to get across is all of these tools are connected somehow. And although the open source community has done a fantastic job making these application deployments readily available with robust operators, such as the Istio operator or ECK, as well as Helm charts with something like GitLab, the devil is still very much in the integration details. So the true value of BigBang, I think, comes from managing and automating this complexity in a repeatable and distributable way. Remember, this is something that we're using at Platform One, but also handing out to other customers as well with various levels of Kubernetes knowledge. So by itself, in this day and age, Helm installing GitLab or something like Istio-CTL installing Istio, not very difficult or very valuable for that matter. But deploying them as an integrated piece of a larger system designed with security front and center is a far more appealing proposition. So with that being said, by leveraging popular community accepted deployment models, specifically for this case, BigBang is leveraging Helm. We're leveraging Flux v2 as a deployment engine. We're able to transparently manage the complexity associated with bootstrapping, upgrading, and operating these interconnected applications, while also exposing consolidated and simple configuration layer for platform engineers to deploy and customize BigBang. BigBang deploys a sensible defaults ready for production out the box for the 80%. Remember, while also remaining configurable for the remaining 20%. And this happens the same way you would deploy any other Helm chart. All right, with that being said, let's jump into the demo. So for this demo, I'm going to walk everyone through a basic installation of BigBang. I'm going to try to keep it as simple as possible, but I will include one minor twist. So at its most basic level, BigBang is a single Helm chart that intelligently is able to reference and deploy interconnected subcharts. So since Helm is heavily leveraged throughout the entire lifecycle of BigBang, that means that every integration out there that has been matured over the lifecycle or over the lifespan of Helm applies to BigBang as well. So one of those integrations that I'm going to be demoing today is the Helm integration within Rancher. So in the interest of time, I'm going to skip directly into the actual deployment of BigBang, and then I'll talk about it in more details as it actually rolls out. So jumping directly into the Rancher UI, I can see going into the apps and marketplace for this cluster that I have provisioned. I have a partner chart already preloaded that points directly to the upstream Helm chart for BigBang. The integration that I get from Rancher is that although BigBang itself is just a Helm chart, oversimplifying things, when I import it as a chart in the Rancher UI, I'm immediately given a interactive user interface in front of the chart. What this allows me to do is simplify the installation process for example, in a demo like this, where I can move into the actual settings and have an interface over the actual values.yaml that the BigBang Helm chart exposes. And what I'm going to do is install BigBang in its most basic settings. Remember, as I said, out the box, BigBang comes configured for 80% of the customers out the box. So what I'm going to do is I'm going to set the one and only required variable for BigBang in its default configuration, and that's the Iron Bank registry credentials. Once I do that, I'm going to scroll down to the install. I'm going to click install. What I should do is I should probably check that's fine. For the purpose of the demo, it doesn't need a name. But what you can see under the hood is all that's happening is a Helm install command. I want to make sure that it's clear that there's really no smoke and mirrors happening under the hood. This is a cluster that is created that has only had Flux installed onto it, and it's using an RKE2 cluster under the hood deployed onto an AWS GovCloud instance. You can see that if I were not using the Rancher UI, all I would have to do to install this would be to helm install, pointing to the actual chart that defines BigBang. If it wasn't through the UI, likewise, I would configure the values.yaml overlays, my custom values to the actual Helm release to make sure I can configure and tune BigBang to my liking. But now that that's actually installed and it's kicked off, well, let's just go back into the Cluster Explorer and I can walk through. So like I said, this is a RKE2 cluster. It is deployed on the AWS on AWS GovCloud. You can see it's not HA and I've under provisioned a lot of these resources. So as Flux rolls out, it kind of hammers the API server. But as this rolls out, you can see I've got 5 nodes. If I go back to the actual deployment, I can see things starting to happen. I've got an OPA gatekeeper that wasn't here before. But let's use the Rancher UI to look at what's actually being installed. And the way that I do that, again, everything is Helm, the integration is all baked in, is I click on the installed applications. Applications as they are defined on this page are Helm releases inside the cluster. The way that BigBang operates, again, the oversimplification is it's just a list of, or it's just a collection of Flux v2 resources that rolls out a predefined and pre-configured software factory. So this has existed for about 2 minutes. I know from experience, Gatekeeper takes 2 to 3 minutes to roll out, and it's completed its rollout. The way I know that is because Gatekeeper, being the first thing that deploys to the cluster, is the blocking application for the remainder of the packages to roll out. The reason it's structured this way is, remember, BigBang manages all the complexity of the rollout of these packages for you. That's the value proposition. Every cluster that has BigBang deployed to it also comes with the constraints of Gatekeeper out the box. And these constraints are what the additional applications use to deploy. So we kind of eat our own dog food there, making sure that BigBang can deploy its own components while staying within the boundaries, when applicable, of how it actually rolls out. You can see more components starting to roll out. Again, these are just Helm releases and they show up on the page here. But I can see once Gatekeeper rolls out, my Istio has started to roll out. Again, this is one of those hard constraints. Istio, in order to fully leverage the Envoy injection, we do that at the namespace level with auto injection. And in order to make sure that Envoy is actually being injected, the mutating webhook that Istio deploys needs to be ready before anything starts deploying. So unlike some other soft constraints where Kubernetes, just being Kubernetes, will eventually reconcile, Istio is one of those hard ones that needs to explicitly be first. Istio must install before something like logging installs. And the reason that is because logging, in this case, it's an EFK stack, fully leverages the Istio sidecar model. So Elasticsearch, the cluster, spins up with Istio sidecars attached to it. FluentBit is only allowed to talk to an Elasticsearch cluster through the strict MTLS that Istio service mesh provides. And in order to do that, these are all things that are automatically being configured by BigBang, by Flux v2 underneath the hood. Again, the point I want to stress is that the operational complexity and the interconnectivity between all these packages is the value proposition of BigBang. These are the things that are being configured out the box for you. Again, I haven't touched this cluster since we first installed it. So while this is rolling out, let's actually see some pods roll out. Again, you see, because we're just leveraging these open source tools, these sort of integrations start appearing within the UI. I'm not going to go into detail here, but that's something that you can look forward to in future demos of BigBang. Let's actually look at some of the pods being rolled out. So I can see if I were to search search for logging, I can see that my Elasticsearch cluster is spun up successfully. Again, same default to the themes of BigBang. So this is a highly available Elasticsearch cluster spread out across different nodes. It's got 3 masters and 4 data nodes. FluentBit, again, deployed as a daemon set across all nodes. shipping logs and shipping certain configurations right off the bat. One of the other things that we'll talk about, if I click on apps, and again look at this, is once Elasticsearch successfully deploys, we'll start seeing some of those soft dependencies that BigBang also handles. So the example I used earlier in the presentation was something like Jaeger. The default installation of Jaeger itself doesn't have persistence towards its traces. It's not a persistent backend. One of the things that being prescriptive, so BigBang is prescriptive about the core components and the add-ons that it chooses to inherit in tree. One of the benefits of being prescriptive, we get to dictate integration. So you'll see once the Elasticsearch cluster is fully up and running, we are deploying Jaeger. And the way that we're deploying Jaeger is specifically interacting with the Elasticsearch backend to really deploy things as we would in a more production-like fashion. And that's it. So give or take about 6 minutes, this deployment, vanilla default deployment of BigBang, which includes all the core components, has successfully rolled out pending this twist-lock deployment, which will happen shortly. But out the gate, you've got the foundations for a good platform. What we're going to do next is we're actually going to try to modify this. So let's say I am a customer who's building their own software factory. I've deployed core BigBang. Now I'm ready for more additional components. Let's say I want to make this thing party bus. The way I would do that is I would edit my BigBang deployment. In this case, remember, I'm fronting this whole Helm chart with the Rancher UI. But let's say I want to start enabling Argo. I want to roll out Argo for customers or for my tenants to consume. If I were deploying the entirety of Partybus, I would enable every single one of these add-ons and more. But let's stick with this for now. Let's just enable Argo CD. So on an existing BigBang installation with core, just like Helm, the way I would upgrade this is I would change the values, run a Helm upgrade, and the way that I see this is through this upgrade process. Again, to emphasize one more time, all we're doing with this Rancher UI is fronting actual Helm commands. So the only thing you need to do is change the values file, run another Helm upgrade, and then Argo or whatever additional application you have chosen to install will be deployed. So again, with this, BigBang is built to be that 80% solution. It is configurable for the remaining 20%. That's something that we're not going to go into today. But let's say I have a unique configuration with the way I want to deploy Istio. Let's say I want multiple ingress gateways. BigBang provides the entry points into those charts to be able to configure them appropriately, anywhere within the boundaries of how you would configure the actual Helm charts. So cool. With that being said, once again, BigBang from zero to hero takes about 10 minutes depending on the environment and depending on the deployment. This was an RKE2 cluster on AWS with all the cloud provider stuff baked in. So EBSs were automatically provisioned, load balancers are provisioned. We're not going to go into the actual details of these applications. You'll have to take my word for it that they do get provisioned with virtual services and you can hit the environments. But please look forward to future demos. In the future, remember, this is just Helm. There's lots of different integrations you can do with that. One of those is orchestrating different Helm deployments, changing the values for different clusters with something like Fleet. Because we're just using Helm, we get to leverage the entire Helm ecosystem for how we do our deployments. So with that being said, I want to thank everyone for their time. I want to thank you for attending. I hope you have a great rest of the SUSEcon. I encourage you to go check out BigBang. Everything is open source. I don't think you even need an account to view this, but if you look at repo1.dso.mil, you should be able to see and search for BigBang, or just click this link. There's documentation there to help you get started. There's different reference architectures that you can use to kind of compare and contrast what Platform 1 uses and what different software factories have used. But yeah, thanks again for attending. See y'all soon.